Hey everyone, welcome back to my YouTube channel. If you are passionate about learning how algorithm actually learn from incomplete data, this video is for you. Today we will implement expectation maximization algorithm from scratch, step by step, and use it to cluster unlabeled data points. But before we start, do not forget to like this video, subscribe and turn on notifications so you don't miss more hands-on machine learning tutorials every week. The EM algorithm, short for expectation maximization, is a statistical technique used when our dataset has missing or hidden latent variables. It alternates between two key steps. First is expectation, that is estimate hidden variables using the current parameters, and M step, update the model parameters to maximize the likelihood given those estimates, and this process repeats until convergence, meaning the parameters stop changing significantly. So now let's implement a EM algorithm for a Gaussian mixture model. First of all, we will import libraries and generate a synthetic data. So here we start by creating two Gaussian clusters, that is data 1 and data 2. Okay, and we will visualize them, and these are the hidden distributions that EM algorithm will try to uncover without knowing their labels. So let me run this. As you can see, there are two clusters in this data. Okay, so now the next part is we will initialize parameters. So let me create a heading and initialize parameters. So here we randomly initialize the parameters, the mean, covariances and weights for each Gaussian component. Let me run it and see. And the next step is we will define helper functions for defining the Gaussian PDF. So our first function is going to be, this function actually calculates the probability density function of a Gaussian distribution, and which is the heart of our each step. This is our Gaussian PDF. Let me try to run it, and now we will define the E step, that is expectation step. So let me create a one more heading, and which will be defined as expectation step. And now let me try to write it down. So def of expectation. In this E step, we will compute the responsibility, that is how likely each data point belongs to each cluster and given the and with the given current parameters. Okay, so let me try to run it. Okay, now the next step is M step, that is maximization step. Let me write the code for it. Def maximization. Okay, and which will take some inputs x and then responsibilities, which was created in the E step. And in this M step, we are going to update our parameters, the cluster means, covariances and weights, to maximize the likelihood based on our responsibilities. And the next step is we will iterate until convergence. We will wait for the convergence and then we will stop. Iterate until convergence. Okay, it will run until the log likelihood stops changing significantly, meaning it's a converge. Here we are using total maximum iterations, that is 50. Previous likelihood is defined as 0, and with each iteration we are updating our parameters. Let me try to run it. As we can see that we have found the convergence at iteration number 5. Now what I will do is that I will try to visualize the result. So let me add one more row and add the heading. Visualization. Okay. So we will define labels equal to np dot argmax, and in which we will pass responsibilities and x is equal to 1. Okay, and now we will define the plt dot scatter, because this is a cluster, so a scatter plot is needed, and then x of start comma 0 and then comma x of comma 1. Okay, and now we will define the c equal to labels comma c map. So this is our code to visualize the clustered points along with the learned means. As you can see that em successfully identifies the underlying Gaussian clusters without supervision. So let's quickly recap what we have learned today. The EM algorithm is used to estimate parameters when the data has missing or latent variables. It also alternates between expectation and maximization steps until convergence. It is widely used in clustering like Gaussian mixture models or density estimations and hidden Markov models. And the best part about this video is you now know how to implement it from scratch. So if you enjoyed this video step by step breakdown, hit the like button and subscribe for more ML tutorials, and let me know in the comments which algorithm should we implement next from scratch. Thank you for watching and see you in next video.